We're gonna have fun here, okay? We've got a small, intimate group. You're gonna be best friends by the end of this. You're at least gonna be best friends with me, so welcome. My name is Danica Fine. I am a developer advocate at Confluent. So there's some key piece of information you can extract there is that I like to talk, developer advocate. And I work at Confluent, so I'm a Kafka person. I really, really like Apache Kafka. How many of you use Kafka right now? Not all of you, so great. We're gonna convert you by the end of this. So yeah, that's pretty much all you need to know about me as a human, that I like to talk, that I like Kafka. The only other piece of information that you could tuck away for later is that I like houseplants. So this is a gift from a colleague of mine. His daughter gave me a little plushy houseplant to take with me every time I give this talk. So this is Jimmy. Welcome, Jimmy. And yeah, so further proof that I like houseplants. Here they are in all of their wonderful glory. This is a subset of my houseplants. In reality, I have about 3 dozen, 4 dozen, I don't know. It's not as bad as it could be. I know some people over the pandemic like really went full in on plants, like they've got a jungle. I try to keep it contained. It's a balance, right? So I love my houseplants. They all have names, as I think they're really wonderful aesthetically, and yeah. I was one of the people that over the pandemic got a ton of plants. You know, I've had plants for years and years and years, but definitely I had way too much time on my hands and got even more plants. And that's wonderful. They look really nice. I'm home all day. I can take care of them. And for those of you who have plants, and how many of you do? How many of you have houseplants? All of you. I love the motivation for coming here. You know how much work it is, right? It's a living thing, okay? You know, some of the houseplants, yeah, you can let them sit there for a bit and you don't really need to touch them, but other ones are pretty needy. And so at the height of the pandemic, what I was doing is like, because I had nothing else to do, was do the rounds, check on all the plants, see if they need to be rotated or watered or fertilized or moved or whatever, I don't know. And then I would do that again at the end of the day because why not? I had nothing else to do. And that was wonderful when I had a lot of time. But then, you know, when you go back to living your life, I ended up with plants like this. They're not supposed to look like that. They're not. This is a very, very sad plant. And what happened is that I forgot to water this one before I went to the office. I came back home, and it's just immediately faced with this guilt. So this is awful. I don't want my plants to suffer like this, all right? And so I asked myself, because I am an engineer, I like to do fun things and build things and whatever. So I asked myself, is there a better way for me to be doing this? For me to be monitoring my houseplants? I just want to know if they need to be taken care of because I'm living my life and I will forget about them, okay? And I know what you're thinking. I can hop on Amazon right now and buy some plant monitoring kit, but that's not a good story. That's not why we're here, okay? So I decided that I wanted to build something, okay? I wanted to actually build a solution to this, right? That's why you're here. So I spent a number of years before being a developer advocate building streaming data pipelines with Apache Kafka in industry. It was a lot of fun, and so I have a lot of Kafka experience. When I became a developer advocate, I decided that anything that I built as a developer advocate, I wanted it to actually be like useful. I didn't want to focus on like toy use cases. I wanted to do something that someone could take and extract information from and build something similar in their lives if they needed to. Okay, so I wanted to build a useful thing. So this is motivation enough for me to do that, right? To bring Apache Kafka into my home, build some sort of solution for monitoring my plants. I also really wanted to build something with a Raspberry Pi for a long, long time, so that was gonna be thrown into the mix as well. So it was really the perfect storm, this opportunity, okay? So let's build a plant monitoring system, right? What would that look like? Well, at this point, the bottom line is that I wanted to just monitor my plants. I just wanted to know if they needed to be taken care of, all right? That would solve the baseline of my needs here, okay? Before you ask, no, this is not an irrigation project because I was a renter at the time of this project, and that seems like a lot to ask of my landlord. Hey, can I set up a bunch of irrigation throughout the house? Sure. So at the very basic level, I just wanted to monitor my plants, okay? So I would throw some soil moisture sensors in these plants, grab those readings, toss them into Kafka. That probably wouldn't be enough, so I'd need some metadata, and I'm gonna do some hand-wavy stuff here as well, and we're gonna throw that into Kafka too. And with all the data in Kafka, then we could start doing some stream processing and use that to determine maybe outliers and figure out which plants actually need to be watered. And at the end, I wanna spit out some alert. I'm a lazy person, or let's not say that. I like convenience, okay? So I want an alert to be sent to my phone, ideally, so we're gonna work on doing that, okay? So at a high level, that's what I wanted to achieve here. So before we get any further, some of you did not raise your hands in saying that you know what Kafka is or that you use it right now. So we're going to make sure everybody's on level footing here. So we're going to cover what Kafka is, right? It is a distributed event streaming platform. Done. I can move on, right? That's probably enough. Yeah, some of you nodded, sure. There's a lot packed in those few words. There's only like 3 really relevant words in that phrase, right? But really, there's a lot. So let's walk through it. So first and foremost, it's a streaming platform. And I have had to clarify this in the past. No, not like Netflix. But Netflix does use Kafka, which just really confuses things for people. But there's a lot of cool blogs and talks out there on like what Netflix actually does with Kafka. It's really cool, so look into it. But anyway, I mean streaming in the sense of what we're doing with our data, right? We're not unfamiliar with that here at this conference. But yeah, I've been undergoing that sort of paradigm shift in how we actually deal with our data, how we move it, how we process it, how we store it, how we look at it. And really, the bottom line is that we want it faster. We want to do things with our data as quickly as possible. And so we're moving away from this batch-focused thing. I'm not saying batch is going away forever, but we have moved from batch to, all right, we're going to look at incremental pieces of information. We're going to process each one as they come through and produce incremental results, okay? We could drive entire systems on these, okay? And there's benefits of this. Kafka is not the only technology that's going to let you do streaming, right? There's many, many more that I'm sure you've encountered here this week. It is one of many, but there's a lot of benefits that you can get from these technologies, right? You're going to build a more reactive system, right? In many cases, you're going to increase the accuracy and results of your data. Especially in the case of Kafka, you are going to build a more loosely coupled system, and actually a more fault-tolerant system in a lot of cases. So there's a lot of cool things that you can get out of it. So Kafka is a streaming platform, okay? More than that, it does some other things. It's not just a streaming platform. It can serve as a messaging system, a persistent storage layer. If you're feeling wild, is Kafka a database? Mull over that for a little bit, yes and no. And a processing layer, okay? So Kafka is a streaming platform, but it's also an event platform. Okay? No, not like Meetup. I just had to clarify all these things. All right. I remember I was telling my parents about what Kafka is in events, and at the end of it, they're like, so yeah, like concerts. They were really like, they just did not, the whole event thing went way over their heads. Anyway, so in order to use Kafka successfully, you need to start thinking in events, okay? If there's nothing else that you take away from this, if you're new to Kafka, this should be it, okay? Really embrace this thing, these events, okay? And this isn't me asking you to rewire your brain. It's not a big ask, because as users, as programmers, as users, as humans, we already know how to think in and process in events. I'm just asking you to be a little more aware of it, okay? So an event, what is it? It's something that has happened. That's profound, I know, it's so profound. But really, what does it mean to say something has happened? Well, okay, you need to know when that thing has happened, right? You need to know who or what was involved and any sort of supporting information. So every time you look at a notification on your phone, that's an event. You're responding to an event. Every time you submit a form online, you're generating an event effectively. So these are things that you do in real life. You already know how to interact with them, okay? Just breaking it down and bringing it into your system design, okay? All right, so for example, bringing it a little more back to the system, I want to be monitoring the moisture levels of my plants. So what would an event be? Well, I could say yesterday at 2:30 p.m., this plant here had a moisture level of 19%. That's very low. That's a sad plant, okay? But breaking it down so that we have that timestamp, that critical piece of when that thing happened, yesterday at 2:30 p.m., we have the thing in question, which is this particular plant, and that supporting details that it had a moisture reading of 19%. Okay, we have all those components in there. We have an event. It happened, okay? Before we move on from this, another thing you really need to internalize here is that events are meant to be immutable. I'm so sorry if that doesn't vibe with you, okay? Just deal with it. And it's not me being a difficult person saying, you can't change this data structure. No, events are things that have happened. They have occurred. We don't have time machines. We can't go back. We're not going to change them, okay? Not yet, at least, all right? So that reading that was taken yesterday at 2:30 p.m., it happened. It has been written. It has been written, okay? But that's unfortunate because that plant is sad right now. So if I want to change that event, well, I'm not going to go back and update that particular event. What I'm going to do is I'm going to water this plant. And then hopefully in the next couple minutes, we're going to get another reading that says, hey, that plant now has a 70% moisture level, okay? So we're not erasing any events, we're not deleting them, we're instead just building up a timeline of events that describe the state of a particular entity in that system, in this case, this plant. So we have a stream of events, or a timeline, that describes that state. All right, so based on this, based on the idea of the streaming platform, you can kind of see how Kafka could be cool, right? All right, we have these immutable facts streaming around the system, and we're using those as sort of golden copies that downstream systems and applications can tap into and use as that golden source of truth and do different things with that, okay? It's pretty powerful, right? But how does it actually do this? And we gotta look into the architecture of Kafka a little bit more, and it's a distributed system. For better or for worse, it is what it is. Some storage basics for Kafka. The primary unit of storage is a Kafka topic, and it is just a data set consisting of these events. You write events into Kafka as key value pairs using a separate client called a Kafka producer. You can have as many of these as you want, writing to as many Kafka topics as you want. Once the data is in Kafka, we use a separate client called a consumer to get those back out. Okay, and again, we can have as many of these consumers as we want, reading from as many Kafka topics as we'd want, within reason, but the limit's pretty high, so. All right, so a couple cool things about consumers, because they're the ones we care about. They're gonna be driving the actual applications that we build off of these events, right? As these consumers read through the Kafka topic and encounter these events, it's probably good if they keep track of where they've left off, right? We wanna be an efficient system, and if these consumers go offline, when they come back up, we wanna be able to move on with where we've been processing, right? So they keep track of that using something called an offset, which is effectively just a bookmark of their place in that timeline of events. Consumers have the ability to work together, which is pretty useful for parallelizing the processing, right? So these consumers group together in a consumer group. We identify that with just a name, and then whenever they come up, they can share that load of processing data from a single topic or multiple topics if you'd want. But more importantly, and this might not sound as interesting, but it actually is that consumers can be completely independent of one another, okay? Multiple consumers have the ability to read the exact same data from the same topic or set of topics and do completely different things with them, okay? And I want to point this out because if this is your first time encountering Kafka, it's easy to compare it to other technologies that might feel similar, like queues, okay? A Kafka topic is not a messaging queue. That is it might feel a little weird because we just came out with new functionality that lets them behave as queues, but the data structure is not a queue. A Kafka topic is based on a commit log. It is a log. And similar to application log files that you use to debug information, when the data is written there, it is there, okay? And no one's gonna alter it. So think about the last time that you read through a log file for debugging purposes. Nothing happens to that data as you read line by line through that log file, right? It's there. Until the log file rolls, which is the same case in Kafka, we're gonna store the data for some period of time until it's stale, right? But while it's in that file, it's there. And so any colleague can come along and try to debug the exact same information or debug something else from that application, okay? Nothing's going to happen to that data. It is there, okay? These consumers, the Kafka consumers, are completely decoupled from the Kafka producers. They don't care about each other. They're never going to care about each other. They don't need to care about each other. And that's really good because we want to maintain a loosely coupled system. The producers can keep writing regardless of how many consumers are consuming that data, and consumers will, for the most part, stay online while they're waiting for data, and that's fine. These topics are further broken down into smaller components called partitions, and these partitions are actually the immutable append-only logs where we actually store the events. Here's an example of it on the right here. So we have a Kafka topic with 3 partitions, and we're going to be writing this data, doling it out according to key in most cases across these partitions, okay? And by breaking it down into those partitions, we are able to take those individual logs and store them across the cluster, all right, because Kafka is a distributed system across the nodes in the cluster. And this is also going to allow us to replicate this data across the cluster, provide better fault tolerance and high availability of that data. Okay, that's enough on that. I know that was a bit of a technical aside, but let's get back to me and the cool thing I did, okay? So this moisture monitoring system that I wanted to build here, what do we actually need to do to make this come together? Well, the first thing is that I need a Kafka cluster. And again, I like convenience. I'm a little lazy, so I'm just going to use a cloud-based cluster that I'm not going to manage myself. I work for Confluent, so this is just a natural choice for me. I'm going to use a Confluent Cloud cluster. There's a lot of cool tools that you get on top of this. Kafka Connect for moving data in and out of Kafka. ksqlDB for in-browser stream processing, and also schema management. But if you want to follow along and do something similar, just have a Kafka cluster running somewhere. I don't care where you're running it. It can be in Docker. It can be on your machine. Who knows? All right. So we have that Kafka cluster going, and now let's get some data into it. So let's focus on the Raspberry Pi and the physical system that I'm building to capture this moisture data. This is not a hardware conference. I'm so sorry, but if you want, I'm not going to sit on this for too long. But again, if you want to build something similar, these are just the general tools that I actually used to build this system. This is my first hardware project, so I thought it'd be a lot of fun to cut and crimp my own wires. So you can just buy those. Please buy them with the connectors already there. Don't suffer like I did, but it was a lot of fun. This Raspberry Pi, overkill. It was the only one, literally the only one that I could get over the pandemic because we still have a problem, but you can probably get away with a 0, honestly, for this. A quick note on these sensors. So these are I2C capacitive moisture sensors. What this means is that any I2C component communicates with the Raspberry Pi using a unique address, okay? All of these components are going to be wired up using the breadboard, and they're going to connect to the Raspberry Pi over the same input wires. So it's really, really important to access the individual components that they have a unique address with which we can access that individual component, right? Most I2C components have the ability to change that address, so you can have multiple of them hooked up. These ones had the ability. Unfortunately, they are so cheap that you can only change the address to one of 4 values. So suddenly, I bought a dozen of these sensors, and suddenly I can only hook up 4 of them at the same time. Yes, there are hardware ways around this. Yes, there are software ways around this beyond the scope of this talk. But know for now that at this point, I could only hook up 4 sensors at a time to my system, which is a little sad. Okay. I put this together, I built the system, wonderful. I'm going to do some hand waving because, again, it's not a hardware conference, and we can start collecting data to put it into Kafka. But before we get ahead of ourselves, just take a breath. Anytime you start any sort of project with data, and most of them have data in it, all of them arguably have data in them, think about the data you're trying to use. Okay, please, just take a step back. It's going to save you so much time. In the real world, when you have more stakeholders, this is even more important. But I was the only stakeholder, so I still like to hold myself to high standards. Okay, so I decided to put together a schema with the data that I'm actually collecting at all parts of this project, okay, just to be a little more organized. So at this point, the data that I'm working with, just the readings that we're capturing from these sensors, pretty simple. We have the moisture value that I'm going to be computing as a percentage. I get temperature for free as well, so I figured I would capture that too. And then I need a plant ID to identify the individual plants. I'm just going to toss that into the schema as well. Okay? And we're also, because things are written into Kafka as key value pairs, I'm going to also use that plant ID as the key for each of these messages. Okay? So how do I get this data into Kafka? Well, I have my sensors hooked up. Now I just need to capture it and produce it to Kafka. There are a couple ways you can do this. Okay? You're either going to use the Producer API or Kafka Connect to actually get this data into Kafka. Producer API, this is your vanilla, low-level option for getting data into Kafka. Okay? And the cool thing is that you have the ability to pretty much write it in whatever client you are comfortable within, whatever language you want to use, all of your favorites, some of your least favorite, so you can challenge yourself if you want to have some fun. You'll want to use the Producer API if you either own or have access to the application that is generating the data. Okay? So if we had some web app and every time someone added something to their cart, I want to generate that event to Kafka, say, I can just add a couple lines, add a producer into the code at that point, and write that data every time that happens. Okay? The other option is Kafka Connect. As the name implies, Kafka Connect is a way to connect Kafka with anything else. Okay? And it's usually data at rest, data at databases, data at the other end of an API call, data that isn't necessarily formed as events, like streaming events right now. We just want to move it from somewhere else into Kafka, or on the other side of things, move it from Kafka out. Okay? What's great about this is that you don't have to actually write any code. It's configuration driven. You point to the data store, the data source, show how to actually connect to it, which tables you want to actually bring in, and it's going to start pulling that data, translating it into events, and putting it into a Kafka topic for you. All right? It's really, really good for integrating with legacy systems. So if you have other databases somewhere else in your system, it's not yet been eventified, and you want to bring it into your streaming system, that's mostly where it's used. All right? What did I end up using in my case? Well, I own the Raspberry Pi. I'm the only stakeholder of this. I'm the only person that matters here, so we're going to use the producer API. I decided to use the Confluent Kafka Python library, and we're going to use a serializing producer. Okay? It is aware of the schema, the Avro schema that I've set up. It's going to serialize whatever objects, whatever messages, according to that schema before sending it off to Kafka for me. All right? Within the script, the first thing you need to know, and this should be a huge red flag, is that I'm going to set up a hard-coded mapping of the I2C address for these individual components mapped to the plant ID that sensor is currently within. Okay? Just at the beginning, I wanted that hard-coded mapping so that I could loop over it and capture the data for those individual plants from each of those sensors and write it into Kafka. So what does that look like? Well, we are just looping over that hard-coded mapping exactly every 30 seconds from here, connecting to the actual component, computing the percentage moisture. There is an error in this code that I forgot to update. Ignore that. And we are capturing the temperature, and we're packaging it according to that schema and that reading object and writing it to Kafka. There's nothing up my sleeve here. It is that simple. We're using the serializing producer. It's pretty straightforward. Okay. So that data is being written to Kafka. Wonderful. It's being generated there every 30 seconds for all of my plants. I have a pretty long history of this data. Now what? Well, every plant has different needs, right? So it's really hard for me to look at that data that's flowing in and say, okay, if it's lower than 20% moisture level, then send an alert. Because for some plants, that's not actually a low moisture level, right? A cacti can go down to like 5% moisture and not care. Okay? So I wanted to be able to tailor this to the individual plants. And so this is where this metadata, this idea of metadata comes in. I needed some additional information on each of these plants to actually understand if I should send an alert, right? So after thinking a bit, I created another schema because I'm an organized human and I do adhere to the best practices, all right? So this is a really long one. It's mostly just a lot of fun information for me if I want to print this out and make this a little more human readable later on. So we have that plant ID, so we can join it back on to those readings, right? We've got the scientific name of the plant, we've got the common name of the plant, we've got the given name of the plant, whichever one you want to use. And then we have the moisture thresholds that this plant is comfortable within. Low moisture, high moisture threshold. And the same with the temperature as well, just because I had that data in there and it might be useful to use one day, okay? So how do I get this data into Kafka? Well, this sort of metadata, this sort of reference data, this is something that should live in a database, right? Or usually would live in a database. But again, I'm a lazy person. I didn't want to run my own Kafka cluster. I definitely don't want to have a database somewhere. So Excel file, no, that's silly. So I'm going to put this data into Kafka directly, all right? That makes a little more sense to me. I'm going to use Kafka as a data store to keep this metadata in there for me, okay? And so what I'm going to use is the producer API here. Even though this plant metadata is slow changing, it's something that probably should live in a database, it's just 4 entries right now, right? I only have 4 plants worth of metadata to write to get this project going, and so I'm just gonna write it directly to Kafka to make use of in my pipeline, okay? I did a lot of guessing and checking at this point to actually figure out which thresholds these plants are comfortable within. There was a lot of research involved, weeks of understanding, when does the plant actually look really sad, and I'm going to take that number and put it into this entry. And so I'm going to build up that object and write it into Kafka. But that's kind of annoying. I could just take that script, basically the same one that I used to package the reading, and use that sort of producer to write it into Kafka. But that means that every time I want to update the metadata, I have to go onto my computer and do that. And I like convenience, okay? So I figured if I don't want to do this, I don't want to touch my computer at all to actually manage this pipeline, what are my other options? Well, since I was going to be sending alerts to my phone, I figured maybe I can also send data from my phone to the Kafka cluster. And we're going to do this using Telegram. How many of you use Telegram? Not enough of you. It's the coolest messaging app out there, okay? It's so cool. It's like WeChat, WhatsApp, but it has a really, really rich API around it, okay? And so what it allows you to do is that you can register a bot with Telegram, you get an API key, and then from there you can build scripts to sort of flesh out what happens when you talk with that bot, okay? And you can insert random Kafka producer code. Why not? So let's collect the data from my phone. All right, so here what I've done is I'm going to use the Python Telegram bot library after I've registered this bot. And with that, it shows you how to authenticate that bot with that API key. And then all you do is you write a Python script to outline how someone interacts with that bot. And you can do arbitrary things with that information, with that conversation. Okay? So here I'm going to outline a high-level conversation handler for what I'm going to do in that conversation. And the goal here is to just collect all of that metadata that I can then package and send off to Kafka at the end of the conversation, okay? So here you outline the different states that someone would go through in interacting with this bot. So first I'm gonna collect the plant ID, then I'm gonna go through and collect all of the names, the moisture levels, the temperature levels. I have some defaults thrown in there as well, and we're just gonna basically define a finite state machine of how we're going through these states, okay? And going into one of these message handlers, here I've already input the low moisture value. And so in this function handler, I am grabbing the low moisture value from user input. I'm going to store it temporarily in state for this conversation. And then I'm going to prompt for the next piece of information and forward it to that next phase of the conversation as well. Okay? And you keep doing this over and over again, and by the end, we've collected all the information in state as a mapping. I can confirm that information, and we can just insert that producer code to produce the data into Kafka, okay? So again, this is gonna look very, very similar to what we saw for the readings data. There's nothing really fancy here. It's a serializing producer that's aware of that schema. So it's going to translate that metadata into a houseplant type, that object, and then produce it to that topic, all right? And so what this means is that when this bot's up and running, this is the conversation flow that we go through. Okay, I want to update a plant. I provide the plant ID that I want to insert into Kafka. I give all that information, confirm it, and it's going to produce it to Kafka for me. So now I don't have to touch my computer. That's wonderful, all right? I can update this information. I can add arbitrary information, and that's great. But I still only have those 4 plants hooked up to the sensors. And I still have that really annoying hard-coded mapping in my production script to actually collect the data from the sensors. So even though I can add a bunch of metadata, I still can't actually leverage that information. So I would like to, right? So how would we do that? Well, I also need to keep track of those mappings. If I don't want to have a hard-coded mapping on the Raspberry Pi script that's running, I need to keep track of those mappings somewhere else. And so where better to do that than in Kafka? So I also need to be able to generate those sensor mappings to Kafka as well. And we're going to follow the same sort of workflow. I'm going to grab another schema, even simpler here. It's just a mapping of sensor ID to plant ID. It's going to be keyed by sensor ID as well. And I can add, using the same method that we just did, I can add another conversation handler to my bot to add a new sensor plant mapping. It's going to, this is an okay place to put a hard-coded list of these sensor addresses that I'm limited to. I select one, tell it which plant ID I want mapped to that, and it's going to write that mapping to Kafka. The only thing I have to do now is make my Raspberry Pi script aware of this mapping. And so I need to add a consumer. I need this data to be present on that script, okay? To consume data, a lot of the same considerations come into play for whether you're going to use the consumer API or Kafka Connect to move data around. In this case, I'm going to use the consumer API. Every piece of information that I put in on those sensor mappings, that's useful, and I want to make use of that in my Raspberry Pi. So what I'm going to do is I'm going to add a consumer to this script. So before it actually starts up to capture data from the sensors, it's going to build up a mapping of 4 values. It needs those 4 values before it moves on, okay, because we have 4 sensors hooked up. And then once it has that 4 dictionary mapping, it can move on. It'll start doing that looping to grab the data. One thing to note here is that I'm going to use a non-committing consumer. Why is that important? Well, consumers keep track of where they left off, right? And so if I read those 4 mappings from the topic, and suddenly this application goes down for some reason, when I come back up, I'm not going to see those 4 events ever again, right? So I want to turn that off. Every time my consumer starts up, I want it to start from the beginning. Never save any of those bookmarks. Always start from the earliest spot in the topic. Another thing I'm going to do is I'm going to make the underlying topic a compact topic. So what we'll do is every so often in the background, Kafka will clean up old values per key. Okay? And so we're going to be a little more efficient in how much data we actually have to read from that topic, but the consumer is going to be able to get all 4 mappings that it needs to start running. Okay? And what I'm going to do is I'm also going to add an additional pull at the end of every 30-second loop so I can get to this information. So every time I add a new sensor mapping, it's going to be reflected in this pipeline within 30 seconds. I can move that sensor and move on. Okay? So this is cool. The first half is the hardest, right? Actually getting the data that you need to do your thing. And we've done that, okay? We have the Raspberry Pi collecting that data. It is aware of these sensor mappings that we are generating, and also we have that metadata being flowing in from my phone. It is pretty event-driven, so let's actually build the stream processing part now. Let's do something with this data. But you have options for processing in Kafka, generally. The OG way to do stream processing with Kafka is with the consumer and producer API. Okay? It's great, it's flexible. You can do it in all the languages that you want to build these clients in. But for stateful stream processing, this is kind of complicated. Because think about the pipeline. You have to bring up a consumer to consume data from Kafka. You do your processing, right? And then you have to produce it back to Kafka. So for stateless processing, that's great. Just do it, whatever, move on with your life. But for stateful processing, you have to do something with that state, okay? Where are you going to put it? Are you storing it on disk? Well, what if the entire machine crashes? Like, what are you going to do with that? You have a lot more questions to ask yourself in that case. And so the next 2 options have made that a little bit easier for you. So moving up in sanity is Kafka Streams. And this is a purpose-built library, a Java and Scala library for stream processing, okay? It's going to take that hassle of state off of your hands. You can spin up many instances of these applications and define a topology on how you're actually going to join data, filter it, map it, aggregate it. You can define custom processing in there as well. You spin up multiple instances, and those instances are going to be aware of how many input partitions are coming into that application. It's going to rebalance those partitions across those running instances, and it's going to keep doing that when any of them go down. And the cool thing is that when you have state involved, it's going to write that state locally and also back that state to Kafka. Okay? So if an entire machine goes down, the entire data center goes down, wonderful, you can still get that state from Kafka and bring that processing up on some other machine later on. Okay? You don't lose your place. If you don't want to use Kafka Streams, if you want to make your processing a little bit easier, we have ksqlDB, which is a SQL wrapper on top of Kafka Streams. I think it's really cool just because it makes it so much easier for you to do stream processing. You don't have to write a full application and deploy a full application. And so, we're just going to use SQL syntax to define what our stream processing looks like, how we're going to map it, how we're going to do our joins, and any sort of aggregations there. And the cool thing is that this is available in browser on Confluent Cloud. So again, kind of lazy, I'm going to use this. All right? The first thing you need to do with ksqlDB is define your inputs. Where are we getting this data, and what does this data look like? Okay? There are 2 main constructs in ksqlDB. There's a table, and there's a stream. Okay? Streams represent ongoing, unbounded events, and tables show the current snapshot of the data set per key. Okay? So let's look at that metadata first. The Houseplant metadata, this should be a table. Right? It's slow changing, and I only really care about the most recent value of that metadata, right? I don't care what the old values were as I was tuning in those low moisture thresholds and that high moisture threshold. I want the most recent one to be present in this processing pipeline. So I'm going to use a very SQL-esque create table statement. The thing that really matters here is we're pointing to which Kafka topic this data exists in. It's in the Houseplant metadata topic, and the value format is Avro. Yeah, pointing this out is really important because ksqlDB as a consumer can access the schema registry where the schema is stored, okay, based on that topic and knowing that it's Avro. It's going to grab that schema and it's going to use it to parse all of the fields and their types. And so I don't have to actually spell out any of the fields and their types here. It's going to automatically do that. The only thing that I do have to point out is, because we're basing the most recent value per key, is just point out which value we're using as the key. Okay, so I'm going to run this in the Cloud Console, and it's going to recognize this data set and bring it in as a table for me to process with. For the readings data, we're going to do a similar thing, but we're going to use a stream, because every event in that readings topic is important, and I want it to sort of trigger the processing. Okay, every reading that comes in is going to trigger something in this pipeline. So we're going to use a CreateStream statement, again, very similar. We're going to point to that Kafka topic, point to the value format, and it's going to bring in all those fields and those values for me. I don't have to actually spell them out. And I'm going to bring in the ID as the key for consistency. Okay. So next, we need to enrich these data sets with one another. All right? So this is a wall of text. It looks kind of complicated. Let's break it down a bit. The thing that matters here is the select statement, right? And this is going to be a select statement that you're familiar with. We're grabbing the fields that we want from the readings data set. We're going to do an inner join on the metadata data set on the relevant field. And I'm going to do an inner join just to make sure I have exactly the data I need to move on. Okay? I can take this statement and I can run it on ksqlDB. And what it's going to do is it's going to output everything that we have right now. Everything that's in the topic, it's going to conduct this join and spit it out. But I want to do something with this data later on, and so I want to persist it somewhere. And so we're going to add this to a CreateStream statement. I'm creating a new enriched topic and stream from this. I'm going to back it by that topic. And again, I can execute this, and what it's going to do is it's going to take the output and put it into that stream, but it's going to stop. And so to make it long-living, to make it be reactive to new data that comes in, I need to add emit changes to the end. Okay? And that's going to say that every time a new piece of information comes in on that readings topic, we're going to execute the SQL, we're going to take the result, and we're going to add it to that stream. Right? So now I have an intermediary stream that I can use to do more things on after this stage. Okay? And that emit changes, that push query is what it's called. That's contrasted with a pull query that I kind of covered a little bit earlier, where it just gives you exactly what is there for now and stops. Okay? All right, so now I have a stream with everything that I need. Let's do what we came here to do, okay? So the goal is that when I have enough low moisture readings, meaning that that plant needs to be watered, I want to receive an alert, okay? But I'm generating these readings every 30 seconds. So I don't want an alert every 30 seconds because that is absolutely ridiculous, okay? I don't want to blow my phone up. That's insane. And so I figure if I'm out and about, if I'm traveling, whatever, receiving an alert every 6 hours would probably be good enough, right? That gives me time, that's a regular interval across the day, it gives me time to do something, to respond, to go back to that plant to water it, or tell someone to go water it for me. And another thing is that I noticed that these moisture sensors aren't perfect, okay? It was like a $1 sensor, right? So there's false low readings, false high readings, but the general trend is that it goes down over time, right? As it should. And so with those two things in mind, you know, I want to receive an alert every 6 hours, but what am I basing that alert off of? Well, okay, I can't say that everything has to be low within that 6-hour window, or that if I have just one low reading in that 6-hour window, then it needs to be watered, because that may not be true. So I figured if within a 6-hour period, if I have 1 hour worth of low readings, that's probably good enough. And so what that means is that I need, if you do the math, I need 120 readings within a 6-hour window in order to trigger an alert per plant, okay? So this is the query that does this, okay? Let's break it down, focus on a couple things. The first thing I'm going to do is I'm going to window this data, right? The enriched data that we just looked at. I'm going to bucket it into 6-hour non-overlapping windows. We have some grace period in there as well for late arriving data. So when it comes in, we're going to split it up into that window. And then I'm going to assess, is the moisture value from that reading lower than the low moisture threshold as defined by the plant metadata? If it is, we're going to count it. And only when it is above 120 do we output a result, okay? I don't want to oversimplify this because it's easy to look at this and kind of forget that we have a stream processing application under here. So within a given window, per plant, we have a state associated with that compound key, okay? So every time that we have a moisture value that breaches that threshold, we are grabbing that state, we are incrementing that value. And then at the end, when we are assessing this output clause, you know, this filter, is it above 120? If so, output something. But then you might be asking yourself, okay, after 120, 121, 122, 23, and so on and so on, do I still get an alert every 30 seconds? Well, that would be not ideal. That would be ridiculous. So I'm going to add a MidFinal to the end. And what that means, contrasted with emit changes, is that we're going to wait for this window to close before we assess that final filter. Don't output anything until that window is closed, okay? So what this means is that per 6-hour window, per plant, we're only going to receive at most one message output on this topic. And so that's great. I have this data, it's being written to a Kafka topic. Now I just need to get it out and put it on my phone. And we're going to do this with Telegram, right? That was the whole point of this. I want to send it to my messaging application. I already have this Telegram bot that I can interact with. And okay, is that useful? Well, with that Telegram bot API key, I can use that. And with the rich API that Telegram provides, I can build up an endpoint that I can send data to that unique conversation that I'm having with Telegram. And so I take that API key, and I'm going to use Kafka Connect. We have an HTTP sync connector that only requires an endpoint, and you tell it which topic to move data from to that endpoint. And so every time a new message comes in on that Kafka topic, the sync connector is monitoring that. It's going to take that message and send it to the endpoint that I need. And so what that means is when it's running, this is the alert that I receive on my phone that guilts me into going home and watering my poor plant. Bradley had a tough time of it that day. And yeah, so I'm pretty proud of this pipeline. It was my first hardware project. It combined all the things that I love. I got to do Kafka and houseplants and hardware, and it was wonderful. But what do you get out of this? Okay, I promise you there's a point. Look, these two things, they look so similar, right? And I promise you, if this is your first time thinking about using streaming data pipelines, you're going to notice that every pipeline you build is going to use some combination of these three things. You're going to need some way to get the data in. You're going to process that data probably, and you're probably going to move that data out, okay? And so we saw how to get data in, either with the Producer API or Kafka Connect, the different ways you can do stream processing, specifically with ksqlDB here, and a couple ways that you can add consumers or use Kafka Connect to move data. And I promise you're going to use, like I said, some combination of those things for your next pipeline that you build. And so I hope you've been inspired. I hope that you'll go out there and build something interesting. Maybe for yourself, take Kafka home. It's a very friendly house guest, okay? So I have a couple resources linked there, including the source code if you want to check it out. So yeah, and I'm at time, over time actually. So if you have any questions, I'm happy to stick around and take those now. Thank you so much.